All right, let's see how you did. All right, let me give you the answers. Let me give you the answers. Imagine a place in the car is most far from all gravitational and frictional forces. Suppose that you visit the place and throw a rock. The rock will continue in motion in the same direction at constant speed. That's pretty easy. Right?
Yeah.
This one, how'd you do? The correct answer is 0, my friends.
How did you get that?
This question is exactly the same as this question. You all told me that an object will continue in motion the same speed, right? But yet here, you told me that it's going to need a force. Why is it going to need a force? An object in motion stays in motion. The key is that it says how much net force is required. The net force has to be 0. Net force means the sum of all the forces. We are used to things happening on Earth that have a friction, right? But if you want to keep something moving, you need a push. But when you push against friction, your net force is equal to 0. So watch out for that question. Remember how I said I was going to ask you that question over and over again? This one? The 50 and the 50? That's the same question. Because what's the net force here? 0. Same question, just worded backwards. Okay? And I'm going to ask you it again. Okay? Correct answer is 0. Number 3. Correct answer is B, Tosh. Inertia does not depend upon speed, but rather mass. Okay? Bigger things are harder to get to move. What depends upon speed and mass is what we call momentum. And momentum is not the same as inertia.
I see a little chart.
So inertia is dependent on mass.
Inertia is dependent upon mass. That's correct. And those of you jotting down little important things might want to jot that down. Inertia is dependent upon mass. Okay? Number 4. Would it require a force to set an object in motion? Absolutely it would. Absolutely it would. The formula is F equals ma. If an object's at rest, then you need a acceleration. And if you need an acceleration, then you require a force. You need forces to cause accelerations. Doesn't matter whether you're in weightless environment or not. What happens to Fred's inertia? Yeah, he's sitting around watching football, eating chips. Of course he's going to get bigger. He's going to increase his inertia. Inertia is the tendency of things to keep on doing what they're doing, which is either staying at rest or moving. Okay, inertia is the ability or the tendency to continue doing what you're doing. What about this moose? The correct answer is B. The moose has more mass, so he has more inertia, so he's not able to make zigzags as easy. Okay? Big, you watch a football game, right? The little running back, he's got less inertia, he can zigzag back and forth. The big lineman dudes, they can't move as fast. They're too big. Think about the Titanic. They saw the iceberg. They're trying to avoid it, but the Titanic was so big that they couldn't make the zigzag. Too much force required. Okay? Big trucks have a lot of inertia. They can't zigzag, right? You don't see big trucks going down the highway going back and forth, right? A lot of inertia. Okay, what about Shirley? She's short. Correct answer is B. The brick that moves more has less inertia and is lighter. If I've got something big and something small, They look the same, and I give them a push, right? The one that's less massive, the one that's lighter, is going to move more. B. What about this fat cat? That is one big cat. Correct answer is B, my friends. Why is it B? Again, this is the same question. I've got 50 newtons down, and I've got 50 newtons up. What's the net force? 0. When there's no net force, the object stays at rest or stays in motion. So he speeds up negatively, speeds up, speeds up, speeds up. Once he hits 50 newtons, then his velocity remains the same. His acceleration is 0. Now, does this happen in real life? Probably not, okay? But what's likely happening in real life is that this 50 newtons is more like probably 150, right? And the cat slows down. We all know that when you jump in the water, you slowly sink to the bottom, right? But I didn't say that. I gave you the values. I said 50 newtons down and 50 newtons up. And it doesn't matter whether it's a cat or a rock or whatever. Okay? The forces are balanced, therefore the net force is 0, therefore the acceleration is 0. So it's B. Which means probably same ratio of people will get this one right or wrong. Correct answer here is A. Okay? He's going to speed up. The dots get farther and farther apart, but then right here the dots remain the same distance apart. Why? Acceleration is 0. I get all that, Sonia, but I told you exactly what the forces were. We're not talking about you jumping in your pool. I'm talking about this particular cat. Okay, and this particular cat has 50 newtons down and 50 newtons up. What's the net force, JC? If you got 50 down and 50 up, the net force is? And if the net force is 0, F net is equal to MA. I got 0 equals 5. What's my A going to be? And if my acceleration is 0, then that means my speed remains the same. Yeah? Yeah?
Yeah.
Okay.
Sure.
Once the cat hits the water, the forces are balanced and the cat will stop. Part of that is true. Which part is true? The forces are balanced is true. But that doesn't mean the cat will stop. If the forces are balanced, what does that mean? Once again, the acceleration is 0, which means his velocity will remain the same. Velocity constant. Well, upon hitting the water, the cat will accelerate upwards because the water applies an upward force. I always have an argument here. Now, you could likely argue, and I would probably agree with you, that there is an upward acceleration. Right? There is an upward acceleration because now you have to go from increasing speed to not increasing speed. So there is a brief moment of upward acceleration. But that's a little tricky out. Will the cat bounce upward due to the upward force? No, because the upward force is balanced, right? Force is balanced by gravity. So the net force, again, is 0. I'm really just repeating myself over and over again here, aren't I? Okay, this is the big daddy one. This is the one that tells me, do you get this stuff? And the correct answer is C. Let's have a look at this. Excuse me.
It could be moving.
If the forces acting upon an object are balanced, then the object must not be moving. Is that true? No, because it could be moving at a constant speed. Oops. Must be moving with a constant velocity. No, because it also could be stopped. Must not be accelerating. That is true, because if the forces are balanced, once again, that means that the net force is 0, which means the acceleration must be 0. Must not be accelerating. Must not be accelerating. How do we do overall? Yeah, 62%.